Hey guys, this is Fraser from Mixed by Tutoring. Today we're going to be looking at Unit 6, Circular Motion and Gravitation, but a specific focus on subtopic. We're looking at this topic. I'm going to talk about the equations later, but first we'll talk about circular motion. And in general, for circular motion, what we need is a force directed. So if we imagine a circle like this one here, like this dotted one here, in order for there to be circular motion, an object has to be experiencing a force that is directly into the center of the circle. And if we have that, that is one of the necessities for that to be circular motion. So we know that whenever we have circular motion, we're going to have a force directed into the center of the circle. And so that answers actually the first part of the question, which is talking about the magnetic force F on the proton. But that's skipping ahead. General good practice with physics questions, as I've already done, is underline certain parts of the question, underline the key parts, which we can use to answer. So circular path, uniform magnetic field, and the magnetic field is directed into the plane. That's important. And actually we could figure that out without this, because the convention is, if we have like X's on the circles, you can almost think of that as like the back of an arrow, right? The fletching on an arrow is like an X. And if it was the front, it would look like this. It would be a circle with a dot. Because if you imagine an arrow, if you would just look at an arrow head on, you would have a dot at the front, and at the back you would have the crosses, right, of the hairs or whatever, the feathers. But it tells us that it's into the plane. So as we know, with any circular motion, the force acting on the object must be acting directly inwards. So if we can just go ahead and we can draw, and let's say the center is here, so we know that F is directed like this. And technically, actually, this should be connected to the proton itself. So it's directed right into the center. And then we need the velocity vector v. So velocity in circular motion is always perpendicular to the magnetic force. So it's either going to be like this or like this. And actually, in order to find this, we're going to have to use the right-hand rule. Now, the reason we're using the right-hand rule is because we're trying to find the direction of current caused by the magnetic field, so the force that it's experiencing. If it was the other way around, as in we have an electric field and we want to, or a magnetic field, if we have like current and we're trying to find the force acting on the object because of that, for example, when magnetic fields interact, then we would use the left-hand rule. But for the right-hand rule, we're going to use the right-hand rule. So you take your right hand, your middle finger is the magnetic field, and that's going into the plane. So your palm should be facing down, and then your index finger, your thumb is showing the direction of force. So it should be pointing into the center of the circle, and then your index finger, your pointing finger, the base of your pointing finger is positive. And the tip of it, where your fingernail is negative. And proton, because it's positive, it's go from positive towards the negative. So it's going to go upwards. Obviously, this is a bit harder. It's going to go this way. It's a bit harder to show this through the screen, but hopefully that makes sense. So it's going to be like a tangent to the circle. That's not good. I'm just going to do a rough drawing like that. And actually, we should label these. So this is F, and this is V. And that should be the answer. You just have to make sure that it's tangent to the circle, so it's not going like this. This isn't V, that's incorrect. It has to be tangent, and it has to be in the correct direction. And you find that direction by using the right-hand rule. Okay, so now some formulas. So again, let's highlight. So speed of the proton, this is the speed of the proton, 2.16 times 10 to the 6. The magnetic field force, or magnetic field strength, is 0.042 T, and we need to find the radius in meters, the radius of the circular path. We need to also give our answer an appropriate number of sig figs, but that's always the case. So we're actually going to be using two formulas here. How to pick these formulas is a bit it's practice really, but it's because we know we have the information that we know, and so we can apply that to the formula. So for example, we need to find, we know that it's going to have to do with this formula. This is the formula for circular motion. Force, I'm just going to write it down without the labels underneath. Force equals mass times velocity squared divided by r, where r is the radius of the circular motion. So we know again I have to use x. It's a circular motion question. We're moving in a circle, and the unknown is r, right? This is 0.538 meters, and what was it? Appropriate significant figures. So we can't be more accurate than our answers. So 2.16, the speed is given with 3 significant figures, right? 2.16, but the field strength is only given in 0.042. Remember, the 0 doesn't count as a significant figure. So that means that we should only go to 2. We can't go to 3 because then technically we sort of increase the accuracy. You always have to give your answer to the same significant figures as the least accurate given constant or given a quantity. So that means there's going to be 2 significant figures. So if we round that to 2 significant figures, 0.54 meters. You might be tempted to say that's 54 centimeters, but they specifically asked for it in meters, so that's the final answer. Hopefully that was clear. These questions are pretty tough. It's difficult to know exactly which formulas to use, but this is a it's a good pattern that comes up. Circular motion, you always use this. Whenever something's moving with circular motion, this is the formula to use, and it depends on what the situation changes the force that's acting on it. So for example, if this was a satellite, we would use this force, but instead of this equation, we would use this equation, but instead of this one for the force, we might use the force for the gravitational force of attraction, right? Because that gravity is acting on it, not a magnetic field. So the force that it's equal to changes from question to question. But the general pattern that we take this equation, we equate it to the equation for the force in that given context, and then we can solve for whatever, for m, for r, for whatever we need to, is a good general framework for how to answer these questions. So hopefully that was clear. I'll be making more of these videos. Let me know if there are other topics that you guys would like to see. I'll be doing some more mechanics questions, that's for sure. Mechanics is a big topic, so those will be coming up. But let me know if there are other specific topics that you guys want me to cover in these videos. Have a great day, and I will see you guys soon.